Hello, my name is Jim Ebkin. In this webinar, we'll discuss technical updates, the status of product improvements related to the HTS900-2-1D engine model. This includes describing system maintenance practices, service bulletins, and line maintenance actions. A couple of particulars on the HTS900 turboshaft engine. It's rated at 1,020 thermodynamic shaft horsepower and at 766 horsepower at 4,000 feet, 95 F. It has dual channel, full authority digital engine control. It's best in class fuel consumption. It has a defined 25% power growth during its maturity path. We'll talk about a few of the highlights of the engine. First of all, it has a two-stage centrifugal compressor, giving it a substantial increase in airflow. It has a reverse flow, a fusion-cooled combustor, a case-tied GP shroud. And that case-tied GP shroud basically will keep the GP turbine tip clearance at its optimum at low power settings as well as high power settings. At high power settings, the case-tied GP shroud allows a minimum of turbine tip clearance, improving efficiency. It has a single-stage power turbine rotor. It has a cooled single-stage gas producer turbine rotor. Of course, we mentioned the full FADAC on the engine. It has an integral Sprague clutch, freewheeling clutch for the Bell 407 aircraft and other applications. Then it has a integral torque measurement system. It's basically a hydraulic torque meter system that determines the engine torque based upon the amount of force that is pushing on that torque meter gear and operating a hydraulic valve, which then tells us how many psi of oil pressure retains the torque meter gear, and that pressure is then turned into a torque reading. It has a cast titanium inlet plenum. Okay, the HTS incorporates a new anti-surge technology. It's called a ported shroud. Basically, at low speeds, you'll see airflow exiting the leading edge of the first stage impeller, and that air exits and goes back into the inlet of the engine. Now, at higher power settings, the second impeller is capable of taking all of the air from the first impeller, and then it actually draws air not only from the inlet of the impeller, but through the side of the impeller to go ahead and feed the second impeller, which greatly enhances the compressor pressure ratio. This ported shroud eliminates the needs for inlet guide vanes, bleed ports, flow fence actuators, and has no moving parts. This is a greatly enhanced design to eliminate additional components. The full authority digital engine control, the FADAC, has several main components. First of all, the ECU has two independent redundant channels within the engine control unit. Second item is a hydromechanical unit. That is basically where the fuel is metered and fed into the fuel line going to the fuel manifold. The next would be the permanent magnet alternator. Permanent magnet alternator, once the engine gets up to ground idle, the permanent magnet alternator is capable of powering the complete ECU and the full-up FADAC control system. It has several sensors, such as redundant NG sensors, gas generator, redundant NP sensors, which is power turbine speeds, has a sensor for the engine torque, sensor for the inlet air temperature, which is the T1, has mean gas temperature sensors, P3 pressure sensors, and that is pressure exiting the second impeller into the combustor. And then the last sensor would be the frangible fuse sensor. It has full diagnostics capabilities for improved troubleshooting. Pilots must observe the advisory panel during helicopter power-up and after engine shutdown for any FADEC system fault lights on the annunciator panel. The built-in test takes about 20 seconds at power up and about 20 seconds after the engine is shut down. Helicopter dispatch with any FADEC system faults is not permitted. If there's an annunciator light with a FADEC fault, data must be downloaded for analysis and corrective action. The most common FADEC incident recorder faults are excessive and incomplete power-up or shutdown tests. Whenever an annunciator light comes on, you must download the data and troubleshoot the system. There's an annunciator light that indicates there's a FADEC maintenance requirement, and that's a light within the annunciator panel of the cockpit. If you have an annunciator light FADEC fault, you must connect the ground station test set to the helicopter. You launch an application per the ground station test set and download the fault codes. Once you get the fault codes, then you must go into the line maintenance manual, the LMM, review the fault code, and take appropriate action. Okay, the HTS in-service maintenance approach. We have the LMM, the Light Maintenance Manual, and this is operational level flight line task instructions. It has special inspections and troubleshooting data. It allows minor external repairs to the engine, and it contains the data to perform a 600-hour periodic borescope inspection of the compressor and the hot section. The Heavy Maintenance Manual provides core engine teardown and reassembly instructions. It includes the data for the 2400-hour hot section inspection and gearbox inspection instructions. It also contains the 4800-hour hot section inspection, cold section inspection, and gearbox inspection instructions. On the compressor section, there is no requirements to disassemble and inspect the compressor section until 4800 hours unless there is something found during some of the borescope inspections. The hot section must be inspected by borescope at 600 hours, 12, 1800 hours, 3000, 3600, and 4200 hours. The hot section will have a teardown inspection at 2400 hours and 4800 hours. The gearbox requires no inspection until 2400 hours or 4800 hours. If there is an auxiliary generator drive installed on the engine, it must be inspected and re-greased every 600-hour interval. Now the accessories, the fuel pump has a 2400-hour functional test and overhaul requirement and a 4800-hour functional test overhaul inspection. FMU is the same as well as the oil pump. The HTS900's 600-hour borescope inspection maintenance has gone extremely well. We've completed 5 inspections. It's typically a 1 or a 2-day customer and service center effort. If you use a service center, there's a big benefit of OJT for your technicians. The service center brought all the tooling and the consumables to site, including the 3mm borescope, a fuel pump spline removal tool, grease, and they brought some minor tooling, which is a micrometer, some gauge pins, and a few small hand tools that were handy. Customers may elect to do their own 600-hour inspections. There's a few pictures on the right-hand side of the slide that show you the condition of these engines, which is exceptional. The compressors have been extremely clean. This is due to the barrier filter that is installed on the Eagle 407 HP. Okay, with Service Bulletin 0006, there's an issue that we've seen on a few engines where the engine may smoke briefly during the commanded engine shutdown after the end of the flight. If there is an engine shutdown during the bit check of the FADEC system, it will indicate a fault code. So the function of the minimum flow valve, it's incorporated to prevent overspeeds. The FADEC system has a built-in test function. When the engine shut down, the min flow valve reduces fuel flow to the engine, and during that reduced fuel flow, the FADEC's computer confirms that the minimum flow valve reduces fuel flow, showing it's functioning properly. The initial design minimum flow valve, the -02, may undershoot fuel flow during this bit test. This is what would cause an abnormal engine shutdown response. It's only maybe 10 to 15 milliseconds of fuel undershoot. We've redesigned the minimum flow valve. The new flow valve part number is the -04. What was added to correct this fuel undershoot was a regulator, a fuel pressure regulator within the minimum flow valve to eliminate possible fuel undershoots. This new valve has a 2,400-hour time between overhaul. The bulletin was issued December 1st of 2017. We request that operators comply at the next borescoper inspection, or if symptoms exist of a bit check engine shutdown. The frangible link is designed to shut down the engine in the event of a number 3 bearing failure. The frangible link is located at the front of the gearbox as part of the thrust retention system. It's also known as a power turbine position detector or a frangible fuse. The frangible link or fuse supplies 2 electrical signals to each engine control unit channel. Okay, our service bulletin 0008 for the frangible link or fuse was due to an uncommanded engine shutdown. During operation, the frangible fuse initiated an engine shutdown due to an open circuit. The FADEC download data identified frangible link or frangible fuse faults on multiple prior flights. During investigation, the frangible fuse showed some minor exterior damage, and it was not from contact with the PT cutter. The resistance check of the frangible fuse was acceptable. We brought the frangible fuse back to Phoenix, put it into a test engine, and determined that the frangible fuse identified an open circuit when it was warmed during engine operation, and it also produced a fault code enunciation. We have a fault tree and a corrective action plan in work. However, the initial action was for us to issue Bulletin 0008 against frangible link or fuse assembly. So there's special fault actions that must take place. We must monitor and check for FADEC fault enunciations at each engine start and shutdown. The flight manual states to allow 20 seconds prior to power up or prior to engine start or after engine coast down to ensure that the bit check in the FADEC is accurate and it identifies any faults. If the FADEC maintenance light is enunciated, the system must be interrogated. If a FADEC fault is confirmed against the frangible link must be replaced and returned to Honeywell. This is identified by confirmed fault word 2, CFW2, or by last engine run confirmed fault word, LCFW2, bit 12. Again, helicopter dispatch with any FADEC system faults is not permitted. We have a spectrometric oil analysis program. This was required in accordance with Canadian certification approval process. It's referenced in the Eagle instructions for continued airworthiness. This requires an initial oil sample be taken from the engine at 2 to 3 hours since engine installation, and then an oil filter backflush and an oil sample taken at 150 hours with the oil change. The oil sample process is fairly simple. You'll take these oil samples, submit them to Honeywell or the lab of your choice. The oil sample will be analyzed and the results will be provided. Use the SIL for guidance if the part per million count of certain wear materials is high. The oil filter backflush is again simple process. However, when we backflush the oil filter, we'll go ahead and get a quantity of materials, the weight of those materials, and then provide recommendations. There have been no unacceptable oil samples submitted to date. Okay, a bit of a tip. When you're changing the engine oil, the oil tank and oil pump must be primed. Leave the oil filter and bowl removed from the oil pump, place container below the oil pump. Fill the oil reservoir with approved oil and motor the engine until oil flows from the pump. Once oil flows from the pump, install the oil filter and filter bowl. Motor engine until oil pressure is noted. Oil purge of the oil pressure transducer feed tube may also be performed. This will ensure that you do not get any false low oil pressure readings during the ground run. The oil pump incorporates a small orifice within the pressure pump gear plates to reduce oil flow during windmilling. This small orifice was a requirement for certification of the engine to the later FAA requirements.